Hello, welcome to everyone. In this video, this is lecture number 13 of an electronic series theoretical part. If you want to watch the previous lecture, you can go through the description box, link are given there. And in this channel, there are various physics related video, some mathematics part with problem solution also discussed. Have different playlist. If you want, you can go through this channel. You will be get different playlist also. Okay. In this video, I want to discuss about the this one, that is the feedback amplifier and op-amp. This is the part 2. In the part 1, we already discussed the feedback amplifier in details. After that, you will be continue this video. It will be beneficial or helpful for you. In this part, we will be discussed about the operational amplifier or op-amp with the black box approximation in detail. That is the actual electronic structure within this black box is not discussed here. That's why we take at the black box approximation. Actually, this is the syllabus of the University of Calcutta, which we want to discuss in this series. So in the operational amplifier we take black box approximation, that is without knowing the internal structure within this electronic circuit within this op amp, will be know about the output terminal and their output. Okay. And the characteristic of an ideal and practical op amp, that is IC-741, that is the IC number of an op amp used actually used in commercially or the practical lab. Then we will be know about the open loop and the closed loop voltage gain, and then finally the frequency response, CMRR, common mode rejection ratio. What about slew rate and the concept of virtual ground? All these things will be discussed in this lecture. Okay, so you can see this is the syllabus of the University of Calcutta 4th semester. This part, that is the circuit and network, semiconductor diodes and application, bipolar junction transistor, that is the BJT, FET, field effect transistor, regulated power supply, amplifier, all are these things covered up in the previous lecture. And the last lecture we covered this feedback amplifier, and in this lecture we want to discuss, that is the operational amplifier up to that one, that is the virtual ground. In the upcoming lecture we will be discuss about the application of op-amp. You can see what are the applications of this op-amp will be discussed in the upcoming session, and in the upcoming the multivibrator and oscillator also will be discussed. So let's start with the op-amp. At before know about the op-amp, you need to know about the IC. IC means integrated circuit. Here IC, that is the batch, IC means batch fabrication. That means hundreds of IC can be formatted simultaneously. At a time, you can generate hundreds of IC. That is the fabrication cost will be reduced using the IC. And this is a very small size and a very small weight, so you can use in the aircraft or the space satellite, etc. In this purpose you can also use the integrated circuit, so it is very useful in your daily life also. The size and the weight we reduce. You can take an example of your laptop, mobile. You can see how this is less weighty, but there are large number of function happening within this device due to this concept of IC, integrated circuit. And this maintenance become also easy, because if you just replace this IC, this is going to as operational. And large scale integration, when you take a large scale circuit, then IC will be help to reduce the size of this large scale integration circuit also. But there's some limitation. How? Very small resistance, that is the less than 1 ohm, or very large resistance, that is greater than few mega ohm, cannot be obtained by this IC. And large capacitance cannot be performed. And importantly, inductor and transformer cannot be fabricated using IC. And performance of PNP transistor is very pure. You know, there is two type of transistor, NPN transistor and PNP transistor. NPN transistor is okay for in case of the IC, but in case of the PNP transistor, IC is not okay. So this is brief things of the about the IC. And for operational amplifier, if you take an black box, this is a black box, that is the IC-741. There is a 8 terminal. IC-741 have the 8 terminal, that is the operational amplifier. Why you will say this is operational? Because in using this amplifier, you know about amplifier, using this amplifier, this gives some operation means subtraction, addition, multiplication, differentiation, integration. This type of operation can be find out, can be obtained using this op-amp, that is the operational amplifier. That's why this is called as operational. Why amplifier? The input is enhanced in the output, that's why this is called op-amp, of amplifier. So operational op and amplifier amp taken as op-amp. Okay, and this is the direct current high gain differential input, and you can see there is 8 terminal. In this 8 terminal, 2 and 3 are the input and 6 is the output. 2 is the inverting input, that means the phase between 2 input and 6 output will be opposite, and the 3 as a non-inverting input, that is the phase of 3 in input in 3 terminal, and the output at 6 will be the same phase, that's why this is non-inverting input. So number 2 is the inverting terminal, and 3 is the non-inverting terminal, and 6 is the output. And 7 and 4, say in the 7 there is a voltage, operating voltage plus VB, and 4 is operating voltage minus V. And 1, 4 and 5 as a connector is a with a potentiometer, that is like that. You know about the potentiometer, there is 3 terminal, 1, 5, and this is 4. So this is the connected, these are the connected port between 1, 4 and 5 to get the 0 set terminal. That means with at 0 voltage difference between 2 and 3, output must be 0 by adjusting this potentiometer. That's why this is called 0 set terminal, and A is the open loop gain, and there is no connection with 8. I think clear. All the port within this IC-741 op-amp. 2, 3 input, 6 is output, 1, 4, 5 set as a connected as a with a port to set 0 terminal. In 7 there is plus V voltage, and in 4 there is minus V volt. So this is the actual connection of an op-amp, that is IC-741. Clear? Next, if you want to know about the ideal characteristics of an op-amp, so input impedance must be infinite, that is the impedance at this point. You can see this is the op-amp circuit symbol of op-amp, you know this is the circuit symbol, and these two terminal sometime cannot use, no problem, that's for that, but you can use. There is plus V voltage, and in this minus V voltage, this is V output, and these two are the V input and V output. Okay, so this is minus and plus, that is the terminal 2 terminal, and this is 3 terminal. This input impedance is the infinite, and the output impedance here will be 0. For this is all about for the ideal of amp. Okay, for ideal of amp, the input impedance is infinite and the output impedance must be 0, and the input open loop gain, that means there is no feedback element. You know about the feedback element, in the previous lecture we will discuss about the feedback amplifier. If there is no feedback element, the voltage gain must be infinite. In the this negative is denoted the out of phase, this out of phase, this negative is denoted the out of phase. And the infinite bandwidth, the bandwidth of this frequency range will be infinite. This is all about for ideal. And the perfectly balanced, that is the this if the voltage difference between two terminal 2 and 3 is 0, then the output must be 0. This is called perfect balance. This balance can be obtained by the 0 set, that is the terminal 1, 4, 5, but in ideal case this must be 0. And the characteristics does not drift with temperature, that means the characteristics does not affected with the temperature. This is all about the ideal, but in practical there is input impedance is 150 kilo volt, kilo ohm to few hundred mega ohm. Output impedance 0.57 to 100, and the frequency voltage gain will be that range, and the bandwidth will be finite and do not as a perfect balance, and characteristics change with temperature. So this is the actual or practical of amp characteristics. Okay, Now comes into the point, that is the open loop gain and closed loop gain. What about open loop gain? That is the gain without feedback is known as open loop gain, and the gain with feedback, so sorry, this is wrong, the gain with feedback is known as the closed loop gain. Okay, if you connecting these elements, feedback element, then it is gain with feedback. If you did not connect this feedback element, then this is called the gain without feedback. Now if you using this KVL, that is the current flowing within the circuit, because you can in case of ideal, there is the input impedance is infinite, so the current cannot go through this path, this current must be follow up this path. So if you write down this current, that is nothing but this, if you take as is a 0, we will be learn about why this is 0, because of the virtual ground. In this lecture will be discussed why this is are known as 0 volt. In virtual ground concept will be clear. So now take as the this point is 0 volt, so this will be also 0 volt. So vi minus 0 by r1 equals to 0 minus v0 by rf. So by calculation you will be get this af, that is voltage gain output by input, will be minus rf by r1. This is the closed loop gain. An open loop gain is nothing but v0 by vi, and this must be 0, because when rf tends to infinite, this is open means infinite, so a will be infinite. Okay, this is the open loop gain. And if you know about the frequency response, the frequency response for open loop gain is like that, and for closed loop gain will be like that, and phase change will be like that. Now know about the important parameter, that is the common mode rejection ratio, CMRR. What is common mode rejection ratio? For that you need to know about the common mode and the difference mode. Common mode is nothing but when these two voltages are common, then output will be 0, as discussed before, that is input impedance high, so this output voltage again will be 0. And the difference is nothing but when there is a difference, the output will be the proportional to that difference. Okay, and this we are taken as the infinite in case of ideal, but in practical this is a high value, and in this common mode this is not 0, this is low value, so their ratio as the known as the CMRR. This calculation you will be helpful to understand the CMRR. So that is V difference, that is the voltage difference between V1 and V2, and common is the average of these two voltages. So output signal will nothing, voltage will be nothing but A2 V2 plus A1 V1, that is the A2 is nothing but voltage gain when V2 is 0, sorry, A1 when voltage gain V2 is 0, and A2, that is the voltage gain when V1 is 0. 0 means this is grounded. When taken V2 ground and V1 get output V0, so this is gain is A1, and similarly for A2. So just changing this V1 and V2 in terms of Vc and Vd, you will be get the value of V1 and V2, and put this equation V1 and V2 and rearranging them, you will be get this one. So this gain is known as the AC, and this is AD. So AC is nothing but the common signal gain in the common mode, that is the same voltage, and there is difference voltage, that is when these voltages are different, that is V1 V2, so this voltage is, this is Vc, this VO is nothing but Vc common, and this VO is the V difference. Okay, so this ratio, gain ratio is known as the CMRR. In dB unit there will be 20 log, like that. Okay, and this corresponding graph with the frequency of CMRR will be reduced with the higher frequency. So this is the common mode rejection ratio in practical. In theoretical this will be this infinite, but in practical there is some value. For high CMRR this tends to be ideal case. So this calculation of CMRR helps to know the characteristics of this OPAMP, where it is practical or tends to the ideal. This will be know about using this value CMRR. Now know about the slew rate. Slew rate is nothing but the maximum rate change of output voltage with the time. Suppose you have a like this op amp. Within that, this inverting terminal connected with output, and this terminal, that is 3 non-inverting, is using this signal, square wave signal. Okay, so this is the input, but in output there is time delay. In this op amp there is time delay between the input and output, because there is a some electronics device, electronics component within this op amp. So there is a there is a there is a shift or time shift. So you can see their input is like that, but in output there is change, and there is a change. So in ideal case this must be along that path. So there is a change in output voltage with like that. So this definition will be this one, that is the dv0 by dt, the voltage change with respect to time at the maximum value. So you can say if this is comes to that one, this is dt 0, so the s will be infinite. For ideal case this will be infinite, and practical this is a high value. So if s is high, slew rate uh, is useful. So for ideal case this slew rate must be high, and IC-741, this value will be 0.5 volt per microsecond. So this is 10 to the power 6 order. That's why the IC cannot be used for higher frequency application. Is this is the problem in case of the slew rate. There is a change in the output with the time. And next and the last topic of today's discussion, that is the virtual ground. This is the important topic to know about this. What do you mean by virtual ground? Suppose you virtual grounds mean actual ground. What is actual ground? Actual ground. Actual ground means this is connected with this ground. This is actual ground. This is actual ground, and in actual ground this voltage is 0, and this current is infinite. Infinite current can be flow to this path. The current tends to infinite. Voltage 0, current infinite. V equals to IR, resistance R equals to V by I equals to V by R. Yes, current tends to infinite. For actual ground, current infinite and voltage is 0, right? Huge number, huge current can be flow to this path, no problem. But in virtual ground voltage is 0, but current also 0. This is the basic difference in terms of voltage and current. In virtual ground, like that, this is does not connect physically. This is does not connect physically. This is connected physically. So this is V0 and I also 0, because this is not connected with ground. That's why current is 0. Okay. So you can see here, for ideal op amp the gain is infinite. Gain means the output voltage by input voltage. So input voltage is nothing but the voltage difference between these 2 point A and B, VA minus VB. Since this is infinite gain, so the input voltage must be 0. So the voltage between these 2 points must be equal. Since this is connected ground with ground, so B point is physically grounded, but you can see the voltage between A and B will be same. So the voltage of A point also 0. The A point does not connected with ground physically, but its voltage becomes 0 due to this operational amplifier op amp. Due to this op amp, this voltage becomes 0 because this internal resistance is infinite. So this must be same. This voltage must be same such that these properties satisfied. That is, the gain must be infinite. If gain is infinite, the input voltage must be 0 because output by infinite. So this becomes 0. So V input is nothing but VA minus VB. Since VB is 0, so VA also 0. VB is connected with physically grounded. That's why this is physical ground. But A is does not connect with physically with the ground. That's why this A is called the virtual ground, because this is voltage is 0, but it's does not connected physically with the ground. You can see the voltage at a node is equals to the ground voltage, that is 0, but this node does not physically connected with the ground. That's why this is known as the virtual ground. I think clear about the virtual ground concept. If there is any doubt, you must comment in the comment. This is all about me, and this is my contact detail. You can connect with me with this Telegram channel, and this is my online platform, and this is my YouTube channel details. Go to this channel, you will get different physics related video, and there is a separate playlist for different part of this physics, some theoretical concept and some problem solution also. Like this session, if you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming videos. So take care, we'll meet in the next video as soon as possible. Thank you.